There's a cross product. That's what they do, a real big solid dot is what they usually do. All right, so for this one, they're saying figure out the dot product. Well, apparently we know the angle is the cosine of 120 degrees, and we have a magnitude of 3 and a magnitude of 5. So that's just going to be your dot product for this one. So let's see. I think I know what the cosine of 120 is. Negative 1/2 times 15. So the dot product is going to be 7.5, negative 7.5. Yesterday we did just the dot product of two column vectors. The dot product of A dot B is equal to, you go negative 3. I like to have it represented this way. You go across like that. And so you go negative 9, then add the next one, negative 2. Add the next one, 7. So it's going to be, what, negative 4? Now, what if this was 0? What would that tell us about the two vectors if it was 0? They're perpendicular. Very helpful. The scalar, probably the most important thing to know about this formula and the dot product is that the number means nothing. The number doesn't mean anything cool like a vector or anything. It only helps us to figure out the dot product. Okay? So the meaning of this is really nothing, but it helps us to relate the angles so that we can determine whether those vectors are perpendicular, parallel, or any other angle. All these are fine. Sure. This one? Sure. So this one, if we look at the dot product, it's going to be 0 times 7 plus 6 times 2 plus negative 6. And did they get 6 for a dot product? Oh, this is the angle. Perfect. So then the magnitude of A is the square root of 0 plus 36 plus 1 is 37. The magnitude of B is 49, and 4 is 53, plus 36 is 89. So the angle is the inverse cosine of the dot product over the magnitude over the magnitude. And then what did you get for an angle? Oh, okay. Did you set it up this way? Then I agree with you. You said 84? I like it. It was a good year. That's the year I got it engaged to my wife. Pretty good. Yeah. On what is it called? Gopher Day. No, not Gopher Day. Groundhog Day. Just kidding. I knew it wasn't. Let's do one of these. I want to do a couple of these because these are, I think Gopher Day is way cooler, don't you? Yeah. Let's just try one of these. I think we should try, let's try B here. Let's try B. If you can do B, all these other ones will fall into place. It says B minus C dot C minus B plus the magnitude of B. So before we go any further, I think we are going to represent these as column vectors. So would you do that, please? Square root of 3, negative 1. C is 1, 1. Okay? Now, for B minus C, what you're going to do, B minus C is going to be a vector. So you take B minus C, which is the square root of 3 minus 1, and then this one's going to be negative 1 minus 1. Then we're going to dot product that with C minus B. 1 minus the square root of 3, 1 minus negative 1. Okay? Then we're going to add the magnitude of b, which is how much? Yeah, square root of 3 plus 1, which is, we'll figure out, here's 2. All right, so now we're going to do the dot product. We're going to dot product these, which is going to be negative 1 negative 1 plus 2 square root of 3, right? Minus 3. So I think this is going to be 2 square root of 3 minus 4. Am I right? Let's try this one more easier way here. 1 minus square root of 3. So this is going to be negative 1 times 1 is negative 1. We're going to have 2 square root of 3's and a negative 3. Yep, that looks good. And then it's going to be added to, this is negative 2 times 2 is negative 4, plus the square root of 4 is 2. So it looks like we're going to have negative 1, negative 3, negative 4, negative 8, plus 2 is negative 6, plus 2 root of 3. Is that what they had in the back? No? Anybody else get that? Negative 6? This is correct. Let me double check my arithmetic here. Negative 2, positive 2. Negative 2 times 2 is negative 4. This has got to be, square root of 4 is 2. So I'm going to run with this negative 6. Where's that? You'd think it would be, but it's square root of 3 times 1, negative, negative. It's going to be plus 2. Oh, that's too bad. Too bad that worked that way. Okay. Any others on that page you want to see? I picked a good one there since there's a discrepancy. And find the values. Would you go to number 7, please? Go to number 7. It says, find the values of x for which the vectors are perpendicular. So x1, negative 1, dot x, negative 2x, negative 1. If they're perpendicular, what should the dot product be equal to? Well, it's equal to the cosine of theta. And what is the cosine of 90 degrees? 0. So that's why we say they're perpendicular if the dot product's 0. Okay? So now when I dot product this, I'll get x squared minus 2x plus 1. So you can see where the x minus 1 times x minus 1 are going to come from. Looks like x equals 1. What does this number 8 look like? 8 is what I did for my father-in-law. I got those 3 points in 3 dimensions. Boom, boom, boom. Made the 2 vectors and then figured this out. Do you want to go through this one or are you good? Yep. Do you want to do this one or are we good with this one? Next one, sure. Yeah, find the unit vector that's perpendicular to both A, which is 3, 6, negative 1, and B, which is 4, 1, 1. So if you're looking for a vector, we do the cross product, and the cross product looks like this. X, Y, oh, you haven't done this? I know you haven't done it. I know you haven't done it, but this is how we're going to do this on Tuesday, or maybe Wednesday. Yeah, Tuesday probably. Would you just take a moment, everybody go to number 10. Do you need some paper, Kaylee? Okay, so you're going to go I, J, K across the top. Then, Ann, which one do you like better, 3, 6, negative 1 or 4, 1, 1? Which do you want to go first? Okay, good enough. It doesn't matter. Either one will be fine, but I wanted to do what Ann wanted to do. Okay, write it down like that. And then what you're going to do is you're going to do something called the determinant of a 2 by 2, which isn't going to make much sense yet, but all you're going to do is do this parenthesis, put an I next to it, put another parenthesis, put a J next to it, put another parenthesis, put a K next to it. This is going to be minus this plus this. We'll get into the details of that later, but I'm just showing you how to do it. So the method that I use is I have you, and this, by the way, will not be on the next test, but it will be on the test after that. Cover up what you have underneath the I. We're going to do the I, cover that up, and then we're going to do what we call the determinant, which is, where are you here? AD minus BC. Okay. What that is A, B, C, D. The determinant of that is going to be A times D this way minus B times C. So what is negative 1 minus 6? Yes, negative 7. Now, when we shift to the J here, this X doesn't really work because you kind of have to go 1 over to here and then minus, it's confusing. So what we do is we just do the big X here. 4 times negative 1 is negative 4 minus 3. So this is going to be negative 4 minus 3. But because we're supposed to start here and go over, we're just going to make it easy for ourselves. That's where the minus comes from. We'll discuss that in more detail. And then the last one is just going to cover up the K. And then you just do this one, which is going to be 24 minus 3. Now, what did I tell you the dot product represented? The answer, what did it represent? Yes, but it doesn't really mean anything per se, except it is a cosine of theta. No, it isn't actually. It's a cosine of theta times the magnitude of A, magnitude of B, but it's just a number. This is going to be much more compelling because this is going to be a what? It's the vector. Not only is it the vector, it is, if these were my two vectors, it's the three-dimensional vector that comes out, that's perpendicular to both of these. So if you hold your hand like this, it's this vector. This is a fantastic tool for finding perpendicular vectors to two vectors in 3 dimensions, or even 2 dimensions. Yes, yes, but this is much more complicated. Yep.